If you're like me, then you enjoy learning new things about math that you never knew before, or that maybe you couldn't even imagine. Rational exponents, also known as fractional exponents, it's one of those things. Let's take a look and see. So hopefully you already know something like what happens when you take the square root of 9. Square root of 9, you get a 3, right? But there's something interesting going on here, and it's like, why is the square root of 9 3? Well, there is another way to take a look at square roots, and I want to point out to you that a square root is actually a type of nth root where the index number is not actually displayed, it's actually implied. And it turns out that related to this too, there's another way that we could work a problem like this. Technically, we could actually rewrite this as 9 to the 1/2 power. It turns out the 1/2 power is exactly the same as a square root. So 9 to the 1/2 equals 3. Now you don't have to take my word for it. What you should do is you should get out your calculator. And on your calculator, depending on what kind of calculator you have, you might have to press the buttons in a number of different ways. Some calculators have something like you'll do 9 and then you'll have a button that looks like kind of an up arrow, but it's not. We call that guy the caret. And then you would put parentheses 1 divided by 2 parentheses, and then finally hit equal. And that should get you 3. You can check it for yourself. It's strange because you'd kind of expect it to be like 4.5, but it's not. It means square root. Now, if your calculator doesn't work like that, you might have a calculator button that looks like maybe x to the power of y or y to the power of x. I can't quite remember. I'm just going to write it like this for now. And then you will, again, parentheses 1 divided by 2 parentheses. And the parentheses are important. Otherwise, you're going to simply raise it to the power of 1, and then you'll divide all that by 2, and you actually will get 4.5. And I don't want you to get the incorrect result. So make sure you use these parentheses. Okay, so anyways, 9 to the power of 1 over 2 is the same as square root of 9, because the square root of 9 has an index of 2. So we put that index down in the denominator of the fraction. Now, there's some cool stuff that's related to this. For instance, it helps us to be a little bit more logical as to why we get a 3. Check this out. If we have 3 to the power of 2, which you know is 9, and we raise that to the power of 1/2, that should be exactly the same as this, right? This should just be 9 to the power of 1/2. Well, the only thing is 9 to the 1/2 here doesn't make any sense that it gets us 3. And square root of 9, there's no good reason why it gets us 3. But 3 to the power of 2 raised to the power of 1/2, there's a perfectly good reason why that gets us 3. It's because this is the same as 3 raised to the power of 2 times 1 over 2. That's what happens when we have a power of a power. And so that essentially is 3 to the power of 1, and that's why we end up getting 3. Now, for those of you who are wondering why we're multiplying those exponents, I'll just really quickly take you off to the side here and remind you guys that if we have something like x squared to the power of 3, that is the same as x times x 3 separate times. And since it is, we know that this must mean multiply 2 times 3 because we get 6 x's. Okay, so go back to this if you're wondering why is it that we multiply the 2 times the 1/2 instead of adding the 2 and the 1/2. There is a situation where we add the 2 and the 1/2, and that's when we have something else, 3 squared times 3 to the 1/2. Then we'd have to add those two guys together. Anyways, let me get rid of those for now. Didn't mean to go down that road. Let's get back on track. I'm just going to finish this video off with a couple last thoughts. If you can change square root of 9 into 9 to the 1/2, then you should be able to take the cube root of something, like let's say cube root of 8, and rewrite that as 8 to the power of 1/3. And same way if we want to take the fourth root of something like 81, we should be able to rewrite that as 81 to the 1/4 power. Now, another thing I'd like to point, oh, and by the way, you should try these on your calculator and see what number you get. Some of your calculators will actually do the third or fourth root. If you have a calculator that will do that, you might see something like this and a little X here. And the way you use it is you do something like, let's say we want to do the cube root of 8. You would put in the 3, and then you'd hit this button with the little X there, and then you would put in 8, and then you might have to do equal, you might not have to, but this is actually a button, and then you'd put 3, then this, then 8, then that. You might have to experiment around with it, but I'd really like you to know how to do this. I'd like you to be able to raise 8 to the power of 1 divided by 3. That's a really useful trick, and it'd be cool if you could try this on your calculator and see what you get. What else? Oh, one last thing. Let's talk about what happens if there's a power. If we have something like, maybe I'll do power in the next one.